In this video, we are going to discuss the concept of molarity. As you know, when you prepare a solution, you dissolve a solute in a given solvent. And you may dissolve a little bit of solute or a lot of solute. So the concentration of that solution is a quantitative measure of how much solute is dissolved in a given solvent. The most common unit of concentration that we use most often in chemistry is molarity. Molarity is defined as the moles of solute divided by the liters of solution, so the total volume of the solution. And we generally abbreviate molarity as a capital M. Here you can see two solutions. Both of these solutions contain the same solute, but in the solution on the left side, we have much more solute particles in the same volume. So this one on the left would have a much higher concentration and therefore a greater molarity. Over on the right side, you can see we have much fewer solute particles in the same volume. So we would have a lower concentration and therefore a lower molarity. So for example, if you dissolved 2 moles of a solute in a solvent and the final volume was 1 liter, you would take 2 moles of the solute divided by your total volume, 1 liter, you would have a 2.0 molar solution. So we would say 2.0 moles per liter, or you could say 2.0 molar with a capital M. So in general, the greater the molarity, the bigger this number, the more concentrated your solution. Let's take a look at a few problems. First problem, what is the molarity of a solution prepared by dissolving 0.23 moles of sodium chloride in enough water to form a solution with a final volume of 0.350 liters? So pause the video and give this problem a try. Okay, so let's take a look at this. We know that molarity is moles of solute divided by liters of solution. The moles of solute, sodium chloride, is given as 0.23 moles. Our final volume of solution is 0.350 liters. So if we divide this, we end up with 0.66 molar, so we have a 0.66 molar solution, or we could express it as 0.66 moles per liter. Either of those would be correct. Okay, let's try to look at another problem. This problem says how many moles of calcium chloride are required to form a 350 milliliter solution with a molarity of 0.750 molar. So pause the video and let's give this problem a try. Okay, let's see how you did. So the first thing I want to do is I'm going to change my 350 milliliters into liters. Now the reason I do that is because molarity is moles per liter. So I can use the molarity of a solution as a conversion factor. The molarity can be used to convert liters into moles. So the first thing I have to do is convert my milliliters of solution, my total volume, into liters. Then I can use my molarity. Notice that I've written molarity not as capital M, but I've written it as 0.750 moles of calcium chloride per 1 liter of solution. So this way it acts as a conversion factor. My milliliters of solution cancel and my liters cancel, so I want liters on the bottom and moles on the top. So 0.750 moles per 1 liter. With moles on the top, I end up with units of moles, and then I can solve and I get 0.263 moles. So 0.263 moles of calcium chloride, if I dissolve that in a total volume of 350 mils, my molarity would be 0.750. So again, molarity can be used as a conversion factor to convert between liters of solution and moles of solute or vice versa. Let's take a look at another problem. How many grams of calcium chloride are required to prepare 1.25 liters of solution with a molarity of 0.500 molar. So pause the video and give this problem a try. Okay, so here I'm wanting to get to grams of calcium chloride. How many grams of calcium chloride? I'm given the volume of solution and the molarity. So here's what I know. If I start with the volume, 1.25 liters, as I mentioned before, molarity can be used as a conversion factor. So I can use the molarity to convert my liters of solution to moles of solute. So 0.500 molar can be written as 0.500 moles of calcium chloride per 1 liter of solution. So this way, my liters of solution will cancel, and I end up with moles of solute, moles of potassium chloride. Now, this is not the end of the problem. I'm asked how many grams. Now, we know that when we're given when you're given moles and asked to convert that to grams, we use the molar mass. So now I can take the molar mass of potassium chloride, which is 74.551 grams per 1 mole. I want moles on the bottom, so my liters of solution cancel. My moles of potassium chloride cancel. See, I want moles on the bottom, and I'm going to end up with grams. So now I multiply everything on top, divide it by everything on bottom, and end up with 46.6 grams of potassium chloride. That's how many grams I need to dissolve in a total volume of 1.25 liters to give me a 0.500 molar solution. So practice a few more of these molarity problems. Be sure you understand what molarity is and how it can be used as a conversion factor to convert between liters of solution and moles of solute.